Good evening to all. In this video we continue our EDA tool tutorial. In this we will see the formality from the Synopsys, and it will be the part 6. Okay, let's start with presentation formality terminal, and then we have the demonstration on the files itself. Okay, so let's start. So in this formality synopsis in this video we are going to see the formality from the Synopsys. Generally this formality is used to compare two RTL and get netlist, and also it can have the ability to compare two get netlist from the two different technology files. Go through the some presentations for the background of how we can do it. So we already know that from RTL to get netlist there is some process. So it involves the design vision or RC compiler. We need to provide the source files, constraints, and the library, and the outcome of that design vision and the RC compiler will be the get netlist and some reports like power area and the timing. For the formality we need the source file as an input, get netlist as well, and the reference technology library, that is .db file, and the result will be like whether it is match or not, or some black box or something like that. It will be come under the results. So we will see how we can provide this all files into formality in TCL files. I am not prefer the GUI style of inputting this data or files to the formality. It is very easy to place in TCL file and have that source. Okay, so we are referring to 45 nanometer library, and the file we need .db file. The basic functionality of formality is that it will compare the RTL with get netlist. Regressive testing whether the functionality of these two are equal or not. In spite of we are not providing any simulation vectors, still it able to find the based on the mathematical approach that these two are equal or not. If it is not, then what are the differences between them? It also reflect on the reports. Supports for complex design, large scale ICs, called the post synthesis verification between the RTL and get netlist. If there is some conflict or unmatch between these two, so we can also do some changes on the get netlist, and that called as a ECO, engineering change order. And for manual doing some alteration on the get netlist, and still we are able to verify that using this formality. For manual changes whether the functionality is intact or not, ECO is also the thing that we can do with the formality. We have the one get netlist for the technology 1, and we map to the another technology, let's say technology 2. Still we can compare these two get netlist with the two different technology database files for the cross verification. So in that sense it is our leverage to have migration from one library to another or one technology to another. Flow is very simple. We need to read RTL code referred as a reference, and the get netlist referred as the implementation. We need to read these two, also the DB file, and we have to provide the top level name for which we are going to compare. And there is simple two commands are there, match command and the verification command, and we can analyze the result or whatever the mismatches between these two, and we can store the results. Loading the database, top level setting, top level model setting, running match and the verification, and analyze the results. So the simple commands for the TCL files are read verilog, read db, set top, match, verify, report, equivalence. And the debug commands are like we have to store the unmatched points, failing points between these two, and set constant is a constant kind of. So the common issues are like unmatched points, black boxes. Okay, so these are the some commands we can use for the that to resolve. Okay, but generally we need to resolve at the source level or netlist level, not by the any flags or any constraint for the tools. Okay, and we are going to perform this formality test on two files. The FSM test one, I hope you remember this file in earlier videos, and one AXI light slave. These two are already we seen in my earlier videos. Okay, we are going for the FSM test one. So the files we required, the main is RTL code fsm1.v, RC or design vision get netlist are there for the test one. So either we can go with the RC or design vision compiler results. So we need only one get netlist. We refer the RC one for this or DV one. Okay, and one DV file we required from the 45 nanometer. We can begin with our terminal. So this will be the GUI kind of thing. We have to provide the references, implementation. These are the details. Okay, we left it GUI. Later on, if you comment we need a GUI tutorial, we can place that also. But after the comment. Okay, thank you. So the AXI related report will be in AXI report, and the final state machines related report will be in FSM test 1 report folder. So I already done this before, so I delete it. So main file is AXI tickle and the FSM1.tickle. So we go with the FSM test 1 tickle first, then we go with the AXI, the details of the tickle file. And please subscribe my channel. So folder FSM1 report, then we can read the Verilog code. It is under the, okay, we can go back to this. There is two folders there. One is reference code and the one is implementation code folder. Under the reference code I put the FSM1.v, which is our RTL, and second is AXI light slave, it is also the RTL code. And under the implementation there is a two results get netlist from the design vision and RC compiler. The RC compiler results for the FSM, this one. So keep in mind that these two folders are in the same folder. We read the FSM1.v as under the read Verilog command for regarding the reference. This is for the implementation container I and container R. So we are reading the test 1 RTL and the get netlist using the read Verilog, and we set the top as FSM test 1. Okay, we read the database file from this location, implementation top level module name. Okay, so just run the match command, verify command, and we can place the report regarding the equivalence, black box, and the unmatched points of the between these two. So black box is nothing but the cell is used but it is not present. Source file regarding that module is not present. Take that as a black box in this report. What is black box in this complete process? So I hope you got the basic things regarding this. This is a tickle file name. Okay, just enter it and compare and generate results. So also we get the report on the console itself, formal verification, matching results. So both are okay, match come as output. You can check the results also. Under this FSM test report it will have the three reports, black box reports. You can check. It doesn't have any black box. Matching verification results. Okay, there is no unmatched points are there. So this kind of result we can see. Even we can go with the GUI also. Start GUI. Under these two options we can see the design details, and even we can go with the schematic of that. Because this is the RTL, because we are going with the R. Okay, and also we can go with the implementation as well. That is our get netlist. You can also check the schematic of the get netlist. I hope you already seen these things earlier in my videos. This is RTL RTL schematic, and this is our get netlist schematic. So both are matched in this case. Okay. So also verification succeed. So we can go with the AXI as well. So we can check the first tickle file for the AXI. We can make the one folder AXI report. We read the Verilog RTL code under the container R AXI light slave, and we are referring the Synopsys or Design Vision get netlist. It is a huge get netlist, so it will take time, and one database from the library. So I just comment these things. There is no need at this level. So we just fire this command from the console, and it will take some time because the get netlist, it is about 2 MB in size. Okay, there are some certain warning regarding the power pins VSS and VDD, so it doesn't matter at this stage because it is a warning. If it is concerned any related to any cells, logical values or logical cells, then we can consider for the debug purpose, but it's okay at this moment. We found some unmatched regarding the registers and some constraints 0x. Okay, and we generate these reports. So we can go back to this and check the reports. So AXI reports, so black boxes report. So there is no black boxes. Verification report, no issue with this. Both are logical equivalence, and the unmatch. Obviously there is a 4 result comes to be as an unmatch. Okay, so these are the details for the what it does mean. Like FF0x means some unconstrained, undefined things are there happening at the DFF. Okay, but it's still okay as far as the logical equivalence are concerned. We can also have the GUI setup for the same. Reference design schematic. For the population it will take time because it is a large design. This is for reference, means RTL. Okay, so we can use, it is very large design, so implementation design. And please make comment to improve or anything that you like to process on this this channel, like on the tool wise or design wise or code wise. I will try to make that happen, and please subscribe my channel. I hope you got the process. It's not big complexity in this as far as the process tool runs, so it is easy. Okay, I hope this video finds useful to you, and please subscribe my channel. Thank you.